filming.
Alright, so next we're at the fuel gauge. This shows how much fuel is in your tank. It's important to remember that the IC must be notified at every quarter of a tank that the fuel goes down. Next we have our gauge panel. This panel mirrors the gauges in the cab. If you see that these gauges are reading abnormally, first check the gauges in the cab to ensure that it is not a gauge malfunction. Next, we have our pressure governor. To activate the pressure governor, hit the mode button. There are two modes, pressure and RPM. To change modes, push the mode button again. To return the pump to idle, push the idle button. When the pump is in pressure mode, it will stop a surge of pressure from affecting the discharge lines and will also protect the pump from the pressure. If the PSI drops to less than 30 and the engine RPMs are 2,000 or above, the pump will return to idle to prevent cavitation. While in pressure or RPM mode, it will hold whatever pressure or RPM you set. The green line on the pump will only tell you that the parking brake is set and the pump is engaged. This green light does not mean that the impellers are turning. There is no way to tell that the impellers are turning. You can only see that by generating pressure. To adjust, use the up and down arrows. To turn off the governor and switch to the manual vernier throttle, use the toggle switch to the right. To ensure the pump is engaged, the center white light and the green lights will be illuminated. Here's your center white light and this right again. Next we have three switches. There are three light switches here. Our panel lights, our driver's side floodlight, and passenger side floodlight. Okay, now we have our discharge gates and gauges. These can be compound or normal. Compound means they also read in vacuum. The gauges are filled with mineral oil to prevent the needle from bouncing. Some of these have a foam capability, and these are listed in red. Now we have our auxiliary inlet gauges. There are two different gates for each auxiliary inlet. One of the gates puts water into the pump and the other puts water into the tank. We have our tank fill and recirculating valve. This can be used to cycle water through the pump to keep it cool and to fill the tank when a water supply is established. We have our auxiliary engine cooler. This valve diverts water from the discharge side of the pump to an immersion radiator to pull heat from the radiator and transfer it to the intake side of the pump. We also have our primer. This valve is connected to a rotary vane positive displacement pump. It uses prime safe oil to maintain a seal and lubricate the parts, which can be refilled on the passenger side of the pump. The oil is consumed in the priming process, which is why it should be refilled. We have our transfer valve. This switch will activate a bronze ball valve, which will change the pump flow from volume, which is parallel, to pressure series. When in volume, the pump is capable of flowing 1,500 GPM. When in pressure, the pump is capable of higher pressures, but only flowing half 750 GPM of the capacity. We have our tank to pump valve. This valve opens the tank and allows water to flow into the pump. This must be open to get water if no water supply is established. We have our water tank level lights. These lights will show the level in the water tank, of water in the tank. Next we have our pump capacity plate. This plate is the manufacturer's test of the pump. When it is put into service, it shows the GPM ratings of various pressures. These pressures are 150 psi, 200 psi, and 250 psi. At 150 psi, you have full capacity of your pump. At 200 psi, you have 70% of your pump capacity, and at 250 psi, you have 50% of your pump capacity. Next, we have our driver's side main inlet. The 6-inch inlet is equipped with a slow operating butterfly valve, which allows water to flow directly into the pump. There is typically a 6-inch to 4-inch reducer attached to it, allowing us to attach our LDH supply line to it. Next, we have our right side compartment. There is a pressure relief valve for the auxiliary inlet behind this door. We have our driver's side main inlet control. This opens and closes the main inlet butterfly valve and is also a slow operating valve. We have our left side compartment. There is a manual throttle behind this door which can be used when you switch to vernier throttle. There is also a ball valve that, when opened, will expel foam in calibration mode, which will allow you to visualize foam flowing through the foam system from the foam pump. We have our front inlet valve control. This operates This operates a slow operating butterfly valve which allows water to flow to the pump from the front inlet. We have bleeders for discharges 1 and 2, our front inlet, and our main inlet. We have our electric transfer valve override. This allows you to operate the transfer valve in case of a failure at the control by using a socket to operate it. A 3/4 inch socket will allow you to move the override. We have our waterless panel, information from the manufacturer regarding the pump. We have a middle compartment which has nothing behind it. We have a pump drain which will allow you to drain all the water out of your pump. We have a pump shift override. This can be used to manually shift into pump in case of air failure. We have our auxiliary inlet. Water taken in here can be directed to the pump or to the tank.